Okay, looking at the root form. So what the root form does is kind of what it says. It gives us the roots. So where x equals 0. So I'll take the negative of the number with the first x and the negative of the number with the second x, and that would give me my roots. So really it's solving for, when we solve for the equation, to find the places where it would equal 0, doing the same thing. So for this, I just take the opposite of it. So my roots would be a positive 3, 0, and a negative 1, 0. Okay, then finding my vertex. Once I've got those roots, I don't have to guess on this. I could go to 3, 0 and put a point. Go to negative 1 and put a point. And so something I know is that these are going to be symmetrical. So my vertex should be on this line at where x equals 1, because that's right in the middle of those 2 points. So when I know that x is negative 1 for the vertex, or not a negative 1, a positive 1, sorry. So it would be a 1 there. Then I can just plug in a 1 for x and solve it. So 2 times 1 minus 3 times 1 plus 1. So that gives me negative 2, a 2, and a 2. When I multiply all that together, end up with a negative 8. Okay, give me that point right there. So I'll do same thing, put in a couple values. So 1, negative 8, 2, 3, and we'll see about 4. And just plug in. Well, I already know that 3 is 0 because I've got that point. But let's see if I put in a 2. So 2 times 2 minus 3, 2 plus 1, which gives me a negative 1, a 3, a 2. So 2 times 3 is 6, times negative 1 gives me a negative 6. If I put a 4 in there, that'd be 5, 10. That'd already be up above where I needed it to be, so we won't even do that. So I've got negative 6 there, which gives me a point there, and also a symmetrical point on the other side. So I know it's going down right here. Got a little bit weird on that end, but you get the idea. So vertex is at 1, negative 8. We've got my roots, we use those to find it. And we've got the axis of symmetry. All those are really just things that are helping us to find out where all those portions of the graph are. Let's look at one last one in the root form. So I need the negative value of this. So the opposite of negative 2 would be a positive 2. So it'd be 2, 0, 2, 0. And so when I put that point on there, we notice that's a double root. And the only time that happens is when that's our vertex. And so our vertex would be 2, 0. And that means that's our axis of symmetry. So let's put a couple points in. If I put in a 3, get 3 minus 2, minus 2, and times negative 1. So 3 minus 2 is 1. So 1 times negative 1 gives me a negative 1. And then if I put in 4, 4 minus 2 would give me 2, 2, and a negative 1. 4, a negative 4. So going from there, I've got 3, negative 1, 4, negative 4, and that means the 5 would probably land at negative 9 or negative 10, somewhere around there. Yep, so negative 9. So we could have that point, but don't necessarily have to have it. Just gives us a little bit better guideline to draw it. So a couple things to notice. When I'm multiplying by that negative, it's always going to flip the graph upside down. And it's also just a -1, so it's not any fatter or skinnier. Just flipped upside down and is moved over a couple places. So when we've got that translation form or that root form, we'll find points pretty quickly, and we're really just trying to find a somewhat accurate graph to go with it.